Hey everyone, and welcome back for another deep dive with us. Today we're going to be looking at direct air capture.
DC.
DC. Yeah, DC. So you probably heard about this.
Right.
It's been making the rounds. This tech that promises to suck the CO2 right out of the air.
Yeah, it's pretty wild.
Yeah, like a giant air purifier for the whole planet.
Exactly.
Sounds pretty sci-fi. But governments are really getting on board. They're investing tons of money.
Yeah.
Startups are popping up left and right. So
there's definitely a buzz.
it's definitely got a buzz around it.
Yeah.
Yeah. But is it the real deal? Can it actually move the needle on climate change, or is it just hype?
Right.
That's what we're going to be trying to figure out today. And to help us do that, we're going to be diving deep into an essay called Direct Air Capture by Jörg-Owe.
Yeah, this essay by Schneppat, it's a great starting point, I think, for understanding DC.
Okay.
Where it came from, where it's going, the potential, the challenges. And, it's interesting that the concept has actually been around for a while, since the early 2000s, but it's only recently that it's really started to gain traction.
So why now? Were we just snoozing on this for 20 years, or what's the deal?
Well, I think, it's not so much that we were late to the party. It's more like the tech needed some time to catch up.
Okay.
Those early DCT methods, they were really expensive.
Yeah.
Not very efficient. But there have been a lot of breakthroughs recently.
Makes sense.
And I think that combined with, the increasing urgency around climate change
Right.
has really pushed DC into the spotlight.
Okay. Yeah. So the tech's gotten better and the need's gotten more urgent.
Exactly.
Okay. So let's get into the nuts and bolts of this. How does it actually work?
So basically, DC relies on a process called sorption. Yeah, it's kind of like selective absorption.
Mm-hmm.
And there are two main approaches. You have liquid sorbents, which use chemical solutions to bind with CO2.
Uh-huh.
And then you have solid sorbents, which use these specialized filter materials.
So they kind of work like a high-tech sponge.
Exactly.
Yeah.
Like a really sophisticated sponge.
Okay.
Designed to capture only carbon dioxide from the air.
Right. So we got these giant sponges sucking CO2 out of the atmosphere. But then what? What do you do with all that carbon?
Yeah.
Capturing it is just the first step, right?
Right. That's a great question. And that's where things start to get really interesting because we have several options.
Okay.
One approach is geological storage, which is basically permanently locking away that CO2 deep underground in these secure formations. But Schneppat points out in his essay that there's also the potential to actually utilize that captured carbon.
Okay, so instead of just burying it, we could actually use it.
Yeah, exactly.
What could you make out of it?
Well, you can transform it into all sorts of things like fuels, chemicals, and even building materials.
Really? Wow, so we could be building houses out of captured carbon.
Potentially, yeah. I mean, it's still early days, but there's a lot of research going on in that area.
That's incredible. So it's like turning trash into treasure.
Exactly. It's a win-win mitigating climate change and creating valuable resources.
So you mentioned it's early days. For all this all sounds super energy intensive.
Yeah.
You're going to need a ton of power to run these DAC plants.
You're absolutely right, and that's something we have to consider very carefully.
Because wouldn't that kind of defeat the purpose? If you're using fossil fuels to power these plants that are supposed to be cleaning up the air.
Absolutely. It would be completely counterproductive. Yeah. And that's why it's so important that we pair DSC facilities with renewable energy sources like solar and wind. Schneppat really emphasizes this throughout his essay.
It's like, you're trying to put out a fire with gasoline. It's just not going to work.
Exactly. Yeah. You need the right kind of energy to make DSC truly sustainable in the long run.
Okay, so we've got to think about how we're powering these things. So it's not just about capturing the carbon. It's about doing it in a way that's actually sustainable. All right, so let's move on to the money part of this.
Yeah.
All of this sounds great in theory, but can we actually afford it?
Right.
What's the price tag on clean air these days?
That is the million-dollar question, isn't it?
Yeah.
And as Schneppat points out, the answer's not so simple.
Okay.
Current cost estimates for DSC, they're all over the place, ranging from a relatively modest $20 per ton of CO2 removed, all the way up to $1,000 a ton or even more.
Wow, that is a huge range.
It is. It is a big range.
Why is there such a big difference? What contributes to such a huge difference in estimates?
Well, I think it comes down to a lot of different variables. Different studies use different assumptions.
Okay.
Different technologies and even different definitions of what cost really means. Some estimates factor in the entire life cycle of the process from capturing the CO2 to storing or utilizing it, while others just focus on the capture phase. So it's a little bit like comparing apples and oranges.
Yeah, so how do we make sense of all this? Like, is DC worth the investment even at those higher price points?
Well, that's where things get really interesting, because the key takeaway here is that costs are projected to decrease dramatically as the technology matures.
Okay.
So just like we've seen with solar panels, right?
Right.
They used to be incredibly expensive.
Yeah.
But over time, they've become much more affordable.
Yeah.
And we expect DC to follow a similar trajectory.
So it's not just about throwing money at the problem. It's about
Right.
investing strategically.
Exactly. Strategic investment and fostering innovation.
Okay. Now let's talk about a concern that I think a lot of people have when they hear about DC.
Sure.
Some critics, they see this as a distraction from the real issue, which is reducing our emissions in the first place. Like, they're worried that this shiny new tech is just going to give polluters a free pass to keep on polluting.
Yeah, I mean, that's a valid concern, and Schnepphat actually addresses this directly in his essay.
Okay.
I think it's important to remember that DC is not a silver bullet.
It's not about giving anyone a free pass. It's about adding another tool to our climate toolbox.
So it's not an either. Like, we can't just rely on DAC and ignore cutting emissions.
Exactly. It has to be a multi-pronged approach.
Okay.
It's like if you're trying to improve your health,
right,
you don't just focus on one thing.
You could do a lot of things, yeah.
Exactly. You
Yeah.
exercise, you eat a balanced diet, you get enough sleep. And with climate change, we need to address it from multiple angles.
Yeah.
We need a transition to renewable energy, improve energy efficiency,
Yeah.
and, yes, reduce our overall emissions. DARES is a valuable tool that can complement these efforts.
I like that analogy.
Yeah.
You know, you can't just rely on one thing to fix a big complex problem like this.
Exactly. It's about combining different strategies for the best outcome.
Okay, so DAC is one tool in our climate toolbox. What does the future look like for this thing? Like, if we can overcome those cost hurdles
Right.
and scale it up effectively, what kind of impact could it have?
Well, if we can bring those costs down?
Yeah, and power it with renewable energy, DAC has the potential to be a real game changer. It could play a crucial role in helping us achieve those ambitious climate targets, like net zero emissions by 2050.
Okay, so for folks who might not be familiar with that term, net zero emissions, that basically means balancing out the amount of greenhouse gases we're putting into the atmosphere with the amount that we're removing.
Exactly.
So we could potentially get to a point where we're taking out as much CO2 as we're putting in.
Exactly. And DAC could be a key part of that balancing act. Schnepphat actually highlights several promising developments in his essay.
Oh, yeah.
That point toward a brighter future for this technology.
Okay, like what?
Well, for example, he talks about Climeworks. It's a company that's built this large-scale DAC plant in Iceland.
Wow.
And it's already capturing thousands of tons of CO2 from the air each year. And it's entirely powered by geothermal energy.
That's amazing.
Yeah.
It's pretty incredible.
So we're using the power of nature to clean up our mess.
That's awesome.
Yeah.
Are there any other, breakthroughs or big investments that you're seeing that show that there's some real momentum building behind today?
Definitely. So the U.S. government has actually committed over $1 billion to funding research and development in this field. So that's a huge investment.
Yeah.
That really demonstrates a serious commitment to exploring the potential of this technology.
Yeah. It seems like people are starting to take this seriously.
Yeah. And, Schnepphat himself.
Yeah.
Well, he acknowledges that there are definitely challenges ahead. He's actually very optimistic about the future of DAC.
Okay.
He thinks it has the potential to really transform our fight against climate change.
It seems like things are heating up in the world of DAC.
Yeah.
And this time I mean that in a good way.
Yeah, definitely.
So we've covered a lot of ground here. We started with the basics of how DAC works.
Yeah.
Then we talked about the cost, the potential benefits, and even some of the criticisms. I feel like I've learned a lot. What about you?
Yeah, definitely. It's fascinating to me how DAC is not just this technological marvel, but it also raises some really important questions about our relationship with the environment,
right?
Our responsibility to future generations, and the role that innovation can play in shaping the world.
Yeah, it's really making me think differently about all of this. And Schnepphat, in his essay, he leaves us with one final question.
Oh, yeah.
Like a real thought-provoking question.
Okay.
He asks us to imagine a future where DBAC becomes truly affordable and widespread.
Wow.
Like, what would that mean for industries, for economies, even for geopolitics?
Yeah.
It's like mind-blowing to think about.
It is a big question.
It's a big question.
Yeah.
And we're going to dive into that question and a whole lot more when we come back after the break.
So if we could actually remove CO2 from the atmosphere, like at a really large scale, it could completely change entire industries.
Wow.
Like, we might see a major shift away from fossil fuels and move more towards cleaner alternatives. Right. And it could also create, like, all these new economic opportunities.
Okay.
Spur innovation and potentially even, like, shift the balance of power globally.
Wow.
Yeah, it's a lot to think about.
It is. It really is. This whole conversation has really changed how I think about DO gas.
Yeah.
Like, it's not just about cleaning up the air. It's like reimagining what's possible.
It is. And that's what I love about these deep dives. You know, they make us think differently, challenge our assumptions.
And you know what Schnippat does a great job of?
Yeah.
Is he really pushes us to think beyond just like the technical stuff. Like, how's this going to work?
Yeah.
But the bigger picture, like, what are the societal implications?
Exactly.
The ethical implications.
Yeah.
Like, it's not just about, can we do this?
Yeah.
It's about, should we do this?
Exactly. And how do we do it responsibly?
Yeah. And I think that's really important because anytime you have a new technology, especially one this powerful, you got to think about the impact it's going to have.
Yeah, you have a responsibility to consider those broader consequences.
Absolutely. And that's why conversations like this are so important.
Right.
The more we understand about these technologies, the better choices we can make about the future.
Exactly. It's about being informed and engaged.
All right. So we've explored the science, the economics, the potential impact of DTAC.
Yeah.
We even imagined a future where it's like everywhere.
Right.
But the real learning starts now.
Yeah.
Like with you, our listeners.
Right.
Like, you take this information and you make it your own.
Exactly. Go out there, explore.
Yeah.
Do your own research. Form your own opinions.
Talk to people.
Yeah.
Share what you've learned.
Yeah.
Because at the end of the day, the future of our planet depends on the choices that we make.
Absolutely.
And those choices are better when we're informed, engaged.
Empowered.
Exactly. So thank you for joining us on this deep dive into the world of DTAC.
Thanks for listening, everybody.
And, you know, I think what Jörg-Owe Schnippat does so well in his essay is he really encourages us to think critically about DAC.
Yeah.
Like, it's not just about the tech itself. It's about the bigger picture.
Exactly.
Like, what are the potential consequences? You know, both good and bad.
Yeah. It's not just, can we do this? It's, should we do this? And if so, how do we do it right?
Right. How do we make sure it doesn't backfire?
Yeah.
Like, we don't want to create more problems than we solve.
Absolutely. We have to be really thoughtful about how we implement these technologies.
Exactly. And that's why I think these conversations are so important.
Yeah.
You know, we need to be talking about this stuff.
Definitely. The more awareness, the better.
Yeah. So folks can make informed decisions.
Right.
About the future they want to see.
Exactly.
So whether you're excited about DAC or maybe a little bit skeptical,
yeah,
I think it's crucial that we all stay informed.
Absolutely.
And keep asking questions.
Yeah. Don't be afraid to challenge the status quo.
Exactly. And you know what? Schnippat's essay is a great place to start.
It is. It's a really thought-provoking piece.
Yeah. So if you're interested in learning more about DAC,
yeah,
definitely check it out.
And there are tons of other resources out there, too.
Yeah. The internet is your oyster.
Exactly. Go down those rabbit holes.
Yeah. Do some digging.
Learn as much as you can.
Because ultimately, the future is in our hands.
It is.
But we can't shape it if we don't understand the tools that we have.
Well said.
So thank you again for joining us on this deep dive into the world of DAC.
Thanks for listening, everyone.
It's been a fascinating journey, and we hope you'll continue to explore this topic with us.
Yeah, keep those minds curious and those questions coming.
Until next time, stay curious, stay engaged, and let's keep building that better future together.